So in this video, we're going to be talking about stoichiometry with multiple compounds. So just to clarify, anytime I'm talking about multiple compounds, I always mean within an equation, within a balanced equation, keyword. So keep in mind that compounds really aren't related to each other. They don't really have some type of exchange rate or anything like that. A good comparison would be like apples and bananas. There's no really good way to compare them because they're different. There's a lot of ways that you could make them related to each other. So you could compare them by weight. You could measure the sweetness. And you could use these specific characteristics to really compare these two fruit. So in the same way, compounds aren't really related, but you can utilize a chemical equation, a balanced chemical equation, to compare them and to convert between one and the other. So here I have a reaction of silver nitrate with calcium chloride to form silver chloride and calcium nitrate. So once again, this is a double replacement reaction. We see that insoluble silver chloride, the soluble calcium nitrate, all that kind of good stuff. And then down here, we see the variation on mole island for these multiple compounds. So just as a refresher from the last video, we had mole island for just a single compound. So whenever we use this, it was moles of CH4, liters of CH4, atoms of CH4, grams of CH4, or any other compound we wanted to plug in there. But when we were working on just this singular island, it was just for one compound or one element. So we didn't have a lot of variation. It would be one individual thing with changing the units. With this, what I did was I went ahead and drew it beforehand so that you guys didn't have to watch me draw the whole thing. But now we can see that there are multiple mole islands connected. So for instance, for this equation, we have a mole island for silver nitrate. We have a mole island for calcium chloride, a mole island for silver chloride, and a mole island of calcium nitrate. And the biggest thing I want you to notice is that all of the moles are connected. So it's just the moles that are connected. None of the other bridges are connected within each other. So for instance, our grams to liters are still not connected, or atoms to grams still not connected. So these are kind of the mole island that we learned in the last video and that we used for the whole last unit. So you see now that each of these compounds have their own set of mole island, and then these are all connected via the mole. So for an example, if we were given a question with grams of calcium chloride, so we have grams of calcium chloride island, and we wanted to figure out how many moles of silver nitrate that would be, we see that we would have to go from grams of calcium chloride to moles of calcium chloride, then to moles of silver nitrate. So it's still the exact same process, it's just a little bit of a variation on it. So one other thing I wanted to talk about this is that a lot of the conversions are going to stay the same, but the most important one I want to talk about was that grams one. So for instance, any of these moles to liters is still 1 mole equals 22.4 liters, and that's still true on all of them. So it doesn't matter which island you're on, 1 mole is equal to 22.4 liters for every single one. So we can go ahead and write that in. Like so. So every single one of those, if you're trying to go from moles to liters or liters to moles, it's still 22.4. If you're trying to go to atoms, that one's still the same. So 1 mole is still equal to 6.02 times 10 to the 23rd atoms on all of them. 10 to the 23rd atoms. It's the same over here. And it's the same over here. But one thing I really want to point out that's super important is that 1 to grams. So for instance, anytime we're talking about grams, we're going to utilize molar mass, and we're going to utilize the periodic table. So for instance, for silver nitrate, we go ahead and find silver. We see that the molar mass is silver nitrate. Silver, we have 1 of those with a molar mass of 107.87. Nitrogen, we have 1 of those with a molar mass of 14.1. Oxygen, 3 of those with a molar mass of 16. So we go ahead and add it all up. Pull out our handy calculator. 16 times 3, get 48. Add it all up, 48 plus 14.01 plus that mass of silver. We get the molar mass of this is 169.88 grams. So I'm going to go ahead and write that down as well, just in case we need it. And again, that's equal to 1 mole. Awesome. So I'll go ahead and write the other ones in as well, just so that we have them. Awesome. So I went ahead and wrote in all of the molar masses for all of these compounds. So just again, you're going to add it all up. So for instance, here's the molar mass of calcium chloride for 1 mole, the molar mass of silver chloride for 1 mole, the molar mass of calcium nitrate for 1 mole, so on and so forth. So for the biggest thing is these molar masses are different. So that means that this conversion is going to be different. So once again, comparing it to postage, if you have a small letter, 1 stamp is good for postage. That pays for the postage. But if you're shipping bricks, it's going to be much more expensive. So for these compounds each have a different molar mass. So that mole total from moles to grams is going to have a different price. So let's talk about moving throughout these islands. So let's say in a problem, it says how many grams of silver nitrate does it take to fully react with 5 moles of calcium chloride. So that's a pretty good example of a question, and it's just saying, from this specific amount of calcium chloride, how many grams of silver nitrate is it going to be taking to really react with it? So my first step for always doing these is to write down what you have and what you're trying to get to. So we see that we were given 5 moles of calcium chloride, and it's asking us to determine how many grams of silver nitrate there are. So I always like to think to myself, what's going to be the process in between? So when we're looking here, we go from moles of calcium chloride, and we're trying to get 2 grams of silver nitrate. So the first bridge we're going to have to cross is this bridge here. So for this bridge here, from moles to moles, what we're going to utilize is the balanced equation. So any of these bridges in here, we're always going to use the balanced equation. Always the balanced equation. So for this, we're going to compare the moles of calcium chloride to the moles of silver nitrate. So we see we have 2 moles of silver nitrate for every 1 mole of calcium chloride. So that means when we set this up, we always start with our given. And this is when it's so important to always make sure you're bringing whatever's up top down to the bottom. So if we have moles of calcium chloride up top, we're going to bring that down to the bottom. And then again, we go from moles of calcium chloride, and our first step in getting to grams is to go to moles of silver nitrate. So that means moles of silver nitrate is going up top. And the way to really know which number goes where is that you have to look to the equation and figure out which number goes with which compound. So for instance, here we see the 2 with silver nitrate. So that 2 is going with silver nitrate. And then with calcium chloride, there's a 1, which is where we're getting that 1 for the moles of calcium chloride. So now we're able to cancel top to bottom, moles of calcium chloride to moles of calcium chloride. Now we have moles of silver nitrate up top, so we go ahead and bring that top to bottom. Always writing that compound. And then our last step is we're trying to get to grams of silver nitrate. So our last step to go from moles to grams is to cross that 1 bridge. And we see that the conversion is the molar mass. So 1 mole is always equal to molar mass. The really important thing out there is that you're not looking at the equation to figure out the number of moles. When you're on these smaller islands, it's always 1 mole. So the only time you utilize that balanced equation is when you're moving from moles to moles. So for moles to grams, it's always going to be 1 mole equals the molar mass, which we found just a second ago. and then moles cancel top to bottom, and you're left with grams. So when we plug this into our calculator, we're going to do 5 moles times 2 times 169.88 divided by 1. We get 169.8 grams of silver nitrate. Awesome. So we'll do a couple more examples, but I'm going to go ahead and stop this one here. That way you guys have a little bit of time to practice.